Okay. Good afternoon. Myself, Mihir Kumar Singha, Chairperson of Future Leader Forum. On behalf of CEI, welcome you all for this webinar on subject design and construction of NATM Scissor crossover. Future Leader Forum within CEI was formed in 2012 with the intention of providing young professionals with an opportunity to participate in CEI, FIDIC, and Asia Pacific and interact with their peers and to develop the next generations of leaders. The main objective of this forum is provide a voice of the young professional with CEAI, increase number of participants in CEAI young professional activities, strengthen the culture of dialogue, organize technical lecture in science, engineering, and architectures, publicize best practice and standards, share success stories about young professionals, provide a supportive space for young professionals to discuss and communicate, enhance the consulting engineering professions. Now I would like to request Mr. Sudhir Dhawan to say something about CEI. He is a long association with Consulting Association and one of the pillars of the association. Currently he is a president of FIDIC Asia Pacific.
Thank you, Mihir. As Mihir has mentioned that we have a future leaders group. Earlier we used to call it young professionals, and the short name that I put was for YPs. So I am always delighted to address meetings of young professionals, and it's a absolute pleasure to talk to them and listen to them and learn many new things. As Mihir has mentioned that CI has a future leaders group, and he is the chairperson for these 2 years. So we would, and we are, as you see, we are promoting future leaders in a big way, and we would like future leaders to come up and start participating in every activity of CEI. As you know, CEI is a professional body, and young professionals should associate with a professional body like CEI, which is the apex body of consulting engineers in India. We celebrated 60 years of our existence 2 years back, and it's a big task for us to keep on working on professional requirements of our members. And we interact with the government, we interact with the banks, we interact with the international funding agencies to promote professional consultancy work from Indian consulting engineers. We are also helping in the export of consultancy services, and we provide financial help also in a small way. So CEI is trying to do its best to promote the professional ethics and quality, and we have a separate division of ethics and quality, and we are going to organize one webinar on ethics and quality later this month, which I would request you to join also. That is very important for young people to groom themselves in good quality and, of course, ethics. Ethics is very important, and if we follow ethics, then the quality also comes in, because then we will not compromise and we'll do our best to provide the best consultancy services for the various projects. Interestingly, everybody, all of you know about the climate change. And with this climate change, we have to change our engineering designs and also the materials that we use. So my desire is that the young professionals should come forward and suggest new materials of construction. It is not an easy task. It is not something may not be made here. But if you come up with ideas, we will go to CPWD and get the specifications modified to include new sustainable material of construction. We are promoting FIDIC conditions of contract in India, and the reason is that all the foreign funded projects, multinational, ADB, World Bank, and JICA, they follow FIDIC conditions of contract. Very few people are aware of those. Only who work on these projects are aware of these. And FIDIC is providing, ADB is providing funding to many agencies on water supply projects, and they need training on FIDI conditions of contract. CEI is doing that. They train people on that. We run training courses, and this you keep in mind, and maybe next time it is announced, please try to join. Also, the FIDIC has introduced FIDIC certified engineers, a new classification of engineers, and this is basically help young professionals to be called FIDIC certified engineers. That will add to your CV and your job, future job opportunities. So we can help you on that also. FIDIC Future Leaders Group has a social media network. We have a Twitter, we have a LinkedIn, and we urge you all to participate and give articles on that, which can be shared also to various members. And it will be a good platform for all of you to know about each other's work. I think I will keep it short, and I am very delighted that new Australian tunneling method is being discussed today. And we have very good speakers, Pratap and Ajay Kumar Singh. And I'm sure you will all participate and enjoy the session. All the best, and look forward to keep in touch with you. Please do come and inform Mihir about what you want to do in CI. Push us fully to do something different in CI for young professionals. We are all with you. All the best. Bye.
Thank you, sir. Now I'm going to introduce moderator of the session, Mr. Ajay Singh. He is a civil engineer by qualification, and over the span of more than 12 years, he has experience in structural design field of steel, RCC, and PSA structures, railway and road over bridge, extradose bridge, pylon and cable stayed bridge design, and bridge health monitoring system design. He completed his post-graduation in civil engineering degree from IIT Kanpur. He is currently working in Doha Engineering Private Limited. Now, hand it over to Mr. Ajay Singh.
Thank you, Mihir. Thank you. Hello, everyone. I welcome all the participants to this second webinar of the series. I would like to thank Sudhir sir for explaining vision and mission of the CIA. So moving forward, today we have this webinar on design and construction of new Australian tunneling method Scissor crossover. As we all know, in modern transport system, the underground construction has become necessity to provide faster connectivity in densely populated city or hilly areas. So these projects affect a large number of surface structure, especially when the cross section of construction is large. So therefore, crossover structure between tunnels is constructed based on NATM design principle for optimized construction and stability during excavation. This presentation is going to be very useful to our young engineers to understand problems and challenges faced during underground construction. So the next portion of webinar is going to be around 70 to 75 minutes, which is divided into three sections. Around 40 to 45 minutes is the presentation by our guest speaker. After that, around 20 minutes, we have discussion and QA session with our panelists. Here, I request all the participants kindly write your questions in QA section and do not write in the chat box, as it creates problem during the presentation. And at the last of the presentation, all the questions would be discussed. And at the end, we have a vote of thanks by Mr. Alok Bhaumik. Now moving forward, let me introduce our guest speaker, Mr. Pratap Muniappa. He has 15 years of experience in tunneling and structural engineering. He is currently working as a lead designer in GeoConsult India Private Limited for an underground projects of Bengaluru and Mumbai Metro. His experience include design of TBM and NATM tunneling, temporary and permanent work design, instrumentation and monitoring design, and ground improvements. So let's not delay further. I request Mr. Pratap to start his presentation.
Yeah. Thank you, Ajay. Thank you for the introduction, and thank you, Sudhir sir. It was wonderful brief about the Future Leader program, and also Mihir, who is initiating this session. Thank you one and all, and welcome to the session. So today we are going to see the challenges which we have been facing in one of our projects. So this is NATM Scissor crossover being built in the Mumbai Metro Line 3. So let's don't delay. We'll go for the presentation. Yeah. So just to cover the contents of this presentation, I'll just give the brief introduction and initial planning of the crossover and proposed alternatives on that. So what was the alternatives which we proposed initially, and which is the finalized alternative? Then the design approach, then the sales excavation sequence, support class, and with the small numerical model and analysis how we have worked out, and summary and conclusion. So basically I will cover the planning, the design, and as well as the construction of the primary support of NATM crossover. So first need to understand what is scissor crossover. Generally we might have seen in most of the railway lines all the scissor crossover, how this is. So it enables the train to change the track from either direction, from one track to another track. So this is more often we could see in the railway lines, so which is switching between the tracks. So what if it is in the underground? Like generally in the underground, these kind of crossings will come in the station areas where we have the cut and cover excavation being done. So we will adopt this kind of scissor crossing within the station space. If not, we use it in the cut and cover where these cut and cover boxes will come. So that areas we generally go with the ramp or box portions. And if not, we go for a big cavern. So in generally, even in after our project, there was a Pune, they could able to fit this crossover within a big cavern kind of construction. So these kind of things we could be able to achieve in the underground space. So, but the problem is, what if the cut and cover is not possible, where we have the surface constraints and we'll have a high risk of the geology above the overburden. So in that case, what if not possible with the methods which we are thinking to go ahead? So with a big cavern, it's not possible. With the cut and cover is not possible because there is a surface, lot of constraints are there. There's no space availability with us to extend the station box. So it is one of the similar cases we have. So that kind of problem statement we have in our one of the projects. So just I'll give the brief of the project. This comes with the Mumbai Metro Line 3, which is having 33.5 kilometers. And this crossover comes in package 6, which is near to Sahar station, which is having an 227-meter length and the maximum cross section width of 16.3 meters with an overburden of 7 to 10 meters. Then, yeah, as I said, the surface structures are too difficult for us to go for the cut and cover, and geology also is not supporting for going with a bigger cavern idea. So this is the project overview. As you can see, this is a package 6. We have the 3 stations. One is Sahar and domestic international airport and international airport terminal T2. So this is the project. We have this crossover in Sahar road. Yeah, this is the area which we are thinking about. This is adjacent to based on the operations and requirements. So this was given an additional scope to build the crossover. This was adjacent to Sahar station. We need to build the crossover. The problem, as you can see, there are a lot of hutments which is adjacent to this, and there's a flyover is also going to T2 terminal, and there's no space even to extend the station, and there's a CSF building which is here. So it's very difficult, and these are the twin boreholes. TBM tunnels are there. So no blasting is permitted because of the airport zone. Then NATM excavation is to be done after the completion of tunnel which is used through the TBMs. So after we complete the TBM tunnels, then only we will be able to do the NATM portion. So these are dense sediments and no space even for the grouting or to do an additional investigation for such kind of structure. So those are the difficulties with at the initial stage. So as the client has given a proposal to go ahead for the initial like to build a crossover, they proposed an initial planning. So we can have a connection of both the tunnels with this kind of structure. So the difficulty of this structure is having, like as you can see, section A is twin tunnels and section BB, which is here. So once we cut, it looks like this. In section CC, we have this. So the problem with this kind of structure, one is we are going the tube with the taper, this one, which is quite difficult, and we don't have a space in between the tubes. Like as you can see, the space between these two is very minimum. So there could be a chances of collapse during the NATM excavation with an unsupported geology, as we have grade 4 kind of conditions above the crown. So that's the reason it is not possible, and even to achieve the taper NATM is quite difficult at this kind of geology. So this initial planning was revised and we went with the proposed alternatives. So first alternative which we proposed, yeah, you just shift a single scissor, like since the station is here, why don't we shift one scissor like crossing to either side of the station, so that it's easier for us to build this station. But operational point of view, this is not possible. So that was again rejected. The second alternative was to have a complete bigger cavern, but we need to do this with the ground improvement, as the space constraint is one of the issue, and we cannot able to delay the station excavations for the ground improvements. So that's the reason only the horizontal grout was the option, but we may not be able to achieve for the entire 227-meter length. So that's the reason we could not able to go with a bigger cavern option with this kind of geology there. Also with the reduced cover. The third alternative, So we shifted the scissor portion to one side of the tunnel, and we able to get more clearance between the tunnels. So this was a third alternative which we proposed after the discussion of the initial alternatives. Then this was finalized with the client and the consultants which were there. So this is how the different sizes of the NATM sections which we have proposed. So we have A, B, C, D, E, F. So these are the 6 types of cross sections which we have proposed to have a connectivity for the scissor crossing. So as you can see, the center line of the scissor which is been pointing near to this tunnel. So this is how we proposed. So now the planning is done for the crossover. So now we need to go for the construction, how we have to proceed with the staged construction for this kind of critical structures with the different NATM sections which is there. So this is the finalized alternative. You can see the conceptual line view of this crossover, how these variations are there. So this is the smaller A NATM section with smaller, much bigger with A, B section and C and D, and this is the junction between D and F, the connection of the scissor with E. So these are the 6 types which we have been used in this scissor crossing. This is downline TBM, which is coming with the both tunnel segments precast, and this is the upline tunnel which is connecting to the stations. Like the design approach has to start with the rock mass type, which was available geological section we have used. Then we had done the behavior checks with the discontinuity failure, shallow stress induced failures, and chimney failures. Then excavation sequence and support class being finalized as per the geological data available. So one of the toughest job is to go with the excavation sequence on these kind of critical sections which was there. So several discussions been held with the internal team, and experts also been taken into consideration for the discussions. So this is the geology of this one. We have a backfill at the top, and again we have a grade 4 weathered rock at a depth of around 7 meters. Then we have a complete grade 3 moss which is there, breccia. Grade 3 breccia is available here. So most of our crossover portion was within the grade 3 and grade 2 area. So still during the excavation, we could see some of the few patches of tough rock, and some grade 4 patches was also present during the excavation. So we could able to counteract the challenges which we came across. This is a typical cross section with the NATM and both tunnels shown here with the geology. So this is the made ground. Then we have a grade 4, then the grade 3 breccia, so then grade 2, and then we have grade fresh rock at the bottom. So these are the parameters, geotechnical parameters, which we have derived from the geotechnical interpretive report with respect to the investigation data, which was available for the Sahar stations. And the joint sets also being defined based on the data which was available with respect to the GIR. So initially, this is how the crossover was looking. The overall sequence we need to plan right now, how we have to proceed for an excavation for twin tube tunnels. As you can see, the steps which you have given, 1, 2, 3, 4. So these are the stages of the tubes which you have taken into consideration. So we'll go in detail how this sections been started excavations. So this is the perspective view with respect to the hutments and the total crossover, how it looks. So this is the station box. So after the completion, this is how the crossover will be looking like this. These are the conceptual views. So, you can see the criticality of the shapes, which you can see in much more detail in this beam model. So as we were talking about the construction sequence, so here comes the challenge. So first, we have the TBM tunnel coming in, and we will have a breakthrough. So this green hatched portion, which is the TBM tunnel, So first we need to wait for the TBM to complete because we don't have any space to do any excavation from the top or anything. So we have to wait the tunnel, TBM tunnel to complete to start the excavation. So next we need to decide, like we have A, B, C, D, E, F, G. So we need to know at which section we need to start the first. So after the completion of tunnel, we have an extra data which is required because we don't have any investigation done on the surface in this area. We have planned to have an investigation within the tunnel. We drill some course and we try to get some information. So that was the proposal given to them because of the time constraints of the TBM. So that also we could not able to do it. But the investigation proposal was also given to the vendor. Then we had the data for the TBM drive because several places at this crossover we had done the face mapping of the TBM. So that data was really helpful in order to get this geological information here. And we did that validation with respect to the NATM excavation. So then we had some ground improvement because since the station is here, at least for some extent of this area, we could able to do some horizontal grouting to protect the hardment zone. So that was not much helpful, but however, it was a very minor ground improvement, you can say. So the next thing is, since the other TBM is not yet come, only one TBM is completed, we have to wait for the other TBM to come. So since the cover is very low in this zone, I will not be able to take this excavation of this block. So we kept a minimum rock pillar cover of 6 meters, considering the one day of the TBM. So we keep that 6 meter, and then we took that. Okay, this is the first section which we need to start. So we fixed that zone of no disturbance zone for till the TBM passes through. So as you can see, I have showed like 6 shapes are there with starting from A, B, C, D, E, F. So this is the height and width of the each section. Like from A is the smaller and F is the bigger section, which is here. So this is A, B, C, D, E, F. So these are the 6 types of sections which we have starting from the thickness of primary laying from 200 to 300. And the final lining of 300 to 450. So as we were discussing, the TBM will be doing the breakthrough in the station in first stage. So we keep the minimum rock pillar for the other TBM to come, and we take the excavation of the C, like ABC, C block at first. Then since we have an advantage of having a bigger block excavation, we can proceed with the smaller block by using 4-pole and rock boards. Thus, that we go in much more detail with the cross-section excavation. I will show you there. So then we finish with the 4. So then we will have this 5-block segment breaking. At this stage, we'll only do the segment breaking because the other TBM has just crossed this and doing the breakthrough in this zone. So then we will take out the complete excavation of this 5th block. Then we go for the bigger block because again once the excavation starts, the mucking process is quite difficult after excavation. So we need to do this, and then we'll obtain the connection between this crossing to have an easy locomotives and everything can pass through. So that's the reason we use this connection. Then remaining 9, stage 9 is the block. Then stage 2. So this is how the planning we did for the excavation sequencing. So we go into deep that how each section is being constructed, so that we will go in depth. So this is one of the C block which was taken. So this is the C block which we were talking. In plan, it looks like this. Since we have 1.4 meter segment width, so this is 1.4. This line shows 1.4. And I've created this 14 meter C block with the 10 blocks in the plan. So as you can see, I'm cutting the segment here in this area. Then I'm proceeding with the smaller excavations. So like, as you can see, 1, 2, 3, 4, 5. These are the segments. 5 segments I'm taking because width also matters for even to move the equipments which are within the TBM, because we are using around 5.8 diameter of the tunnel. All the equipments has to come through this and start breaking. So it needs some space for the excavation. So we'll have 1.5 meters excavation after breaking of the segments. Then we proceed cross section with 1.5 meters for the complete block. So once we like as we are saying, this is the segment in the cross section. If you see, this is the segment. So before breaking the segment, I need to protect the ground which is at the top. So we did some GFRP boards from the tunnel itself with the staggering pattern. Then we did some drainage drillings for the segments, basically in the crown area. Then we proceeded after breaking the segment. This is the breaking of segment. Then we proceeded small area with respect to 1.5 meters. So this is how the primary supports are coming. Then sequentially we went 1.5 meter blocks A, B, C, D, E in order to achieve the complete heading by installing the primary support of GF rock bolts and shot pit. So this is how the cross section excavation is being built. And once the top heading is done, this is how it looks with the bolting and the shotcrete arrangement. So now the C block is already built with the primary support. Excavation is done. So now the full phase is available here. Since the B block is smaller compared to C block, we have an advantage that full phase excavation can go. As you can see in the cross section, this blue highlighted is a C block where I have a full phase, and this small one which is the B block which I am going to excavate here. So I have an advantage now to install the 4 poles here. As you can see, these dotted dots are the 4 poles which we are installing, and we have an advantage of going with the full phase excavation, and even the segment breaking is quite easy. I don't need to go with the sequential excavations of 1.5 meters or breaking each segment. So I have a space which is backside also to break the segments now. So like this, incrementally, like each heading, we are going in a full phase and completing this B block. As you can see, full phase excavation we are doing by doing the breaking and everything. And one thing is that we have not used any blasting here. We have only used the breakers to do the excavation here. It's because this is a very sensitive zone which is near to the airport. There is no blasting is allowed on these zones. So now after completion of the B, this is how it, along with the 4 pole and the rock bolt arrangements with the short pit, this is how the primary support excavation looks. Yeah, this is the stage 4 excavation after the completion. So like this, incrementally we have gone to all other excavations, like others. Similarly, once we have the bigger block advantage, we have gone to the smaller blocks. So similarly, we have used the 4 poles and rock bolt arrangements to do the excavation with a varying of 200 to 300 short pit depth. So we had checked the discontinuity analysis by using unwedge modeling. Then the numerical models we have worked on, and each section has been checked with the RS2. We had checked the sections here, and this is the discontinuity results where the factor of safety will be kept minimum 1.5 the achieve. So this is the left and right wedge, the upper wedge, and this is the wedge analysis which we have done without support, and this is with supports. So this was the without support results, and this is with the supports. We had a stable, and all the results were fine. And this is the FEM results. So this is the deformation of the sprayed lining at crown and side wall and inward. So each section we have here B, C, and B, F. So this is the surface settlements, which was quite nil. Around 6 mm is the maximum settlement which we were there. So even during the excavation at site, so we could not get much settlements during the excavation. So This is the structural capacity check. So all the points were within the limits. So as we were discussing about the site progress, so this is the station, which is Sahar station, that is been built with the bottom-up excavation. These are the secant piles with the veiler arrangement. So this is the twin tubes which we are talking about. So this photograph was clicked during the breakthrough of the upline TBM, which was there. So this tunnel was completed, and the excavation of the crossover is already started within this TBM. So as we were saying, these are the hutments which is on the surface, which is very crucial for us to even enter through any grouting equipments or anything. So there was no space, and people are leaving, and there's no evacuation plan or anything which we proposed on these areas. So only we have kept a complete monitoring of the area, and surface monitoring was quite tight. And this was one of the building, which is the CISF building. The military team was staying here. So this hostel, CSF hostel was there. This is a multi-story building. So we could take an advantage of this one in order to have an top view of the hutments, where we had a few additional instruments being put in most of these buildings. So this is how the cross-section excavation we started. So all these red marked portions you can see here. So these are the GFRP bolts which we inserted before the breaking of the TBM. Like as you can see, staggering pattern we have done this GFRP bolts in order to hold the stability of the rock mass behind the segments during the breaking. So we sequentially we started breaking the segment like this, and we have just gone with, like as we were saying, the cross-sectional increment of the excavation. So we were installing the primary supports and going with the sequential excavation. So this is how the short bit been done at this site. So this is how once the block is complete. So this block is completed, as we were saying about C block. Then the smaller block is here. So you can see the four poling arrangement with the smaller block here. So we have an advantage now to break the segment in one go. So complete heading excavation we can able to do in one go here. So you can see multiple views here. So this is one of the challenges. Like in between, we have got a tough rock. The strength is too high for this, but it was even most of the breakers we could not able to do, and we have to change the breakers also during the excavation. And one of the patches also we got very damp patches of grade 4 and clay kind of material in these areas. But we could able to do it some small grouting in this zone, and we able to revise the support class with an additional bolting and the short grid layers here. And this is the two-stroke zone, and even the seepage was also been encountered in few of the areas. So that also been tackled, and the dewatering was in place whenever the seepage issues are there. Especially in the monsoons, the seepage was increasing. Yeah. So this is the primary support of the complete sections. This is the invert concreting was going on during this session. Like as you can see, the variation of the shapes being completed at area, and this is how the crossing was taking place. This is one of the bigger sections which we have here. Then how this the blocky where we have this crossing from one tunnel to other tunnel. So the photographs being taken from that area. So this is after the completion of the primary support, and most of these different sections which we have achieved at the excavation. So this is how it was looking after the completion. So this is the, like from block A, B, C, D. So this is how the variation of the each blocks which were coming. And this was the actual excavation being planned with the conceptual view. And this was we would able to achieve the complete excavation in the similar whatever the conceptual view was showing here. So So in order to discuss about the constraints and the conclusions, like after the excavation of this crossover. So most of these site fences were with an optimized geometry, and the sections were checked for the maximum settlements, which was only 6 mm. And this was the first ever crossover being built for with using the NATM, that too with the complicated sections with around 6 types. So in urban environment with such critical area, so that is one of the achievement which the contractor and all other design team were involved. And there should be one more session because geotechnical monitoring was one of the thing which we need to look into it, because this monitoring is we have taken real-time monitoring also in place in few areas in order to have complete care of the NATM excavations. Even with the NATM, we had a lot of instrumentation done after the primary supports. This one, and we have done the behavioral checks regularly, and it was reported. So then we able to tackle the support optimization and corrective measures, like as we were seeing some damp patches of grade 4 and weak zones. So we could able to revise the support classes which we are proposed there, and we could able to do some additional support classes to work on at site. So this is how we could able to tackle the support classes. Then the change in water table and the geology was also encountered during the excavations. So those are all expected because we got the TBM data earlier, where we could able to see that some of the geology is changing from all along this 227-meter length. So that data was quite helpful in order to get an overview of this one. So a lot of work being done in order to study before doing an excavation. So this is the summary of the total excavation of the NATM and the conclusion. So, and thank you all. Thank you for your time. Over to Mihir.
I would just add few words, Pratap. I am
Yes, sir.
quite fascinated and what has been done or being done, and it's a tremendous task. I mean, seeing the hutments, one that's forts, how how will you do tunnel below these hutments? And hutments are so tiny and
Yeah.
so delicate that they can collapse anytime. Very good, very good. It is
Thank you,
a
sir.
very useful information for me. I've learned first time this. Thank you.
Okay, thank you, Pratap, for such an informative presentation. So now we can start our question and answer and discussion session. We have a few questions from our participants. So let's take up one by one on them. Uh, so here is Sunil Kumar Singh. He asked how much minimum width we have to maintain in between two tubes.
Yeah, basically when we have a good rock, like considering grade 1 2 kind of rock mass, so we will have very minimum this one. So practically we'll have a thumb rule of having one dia of the tube. Like if you have a 6-meter dia of the excavation being done, we should at least have a clearance of 6 meters. So that's the kind of thumb rule in any geological conditions. But with an improved ground and with a good rock, we could able to reduce that spacing.
Okay. And the next question is from Harinder Singh, that how was the 200 or 300 thick short grate applied?
Yeah, we have a like every 100 we have a wire mesh we have done. So with the wire mesh, we could able to achieve one more layer. So like as we were going, the phase shortcuts was in place with 50 and after the sequential excavation, once the section is complete, we could able to do the wire mesh by handling that wire mesh with stitches. Then each layer of wire mesh is been done, like 100 150 they were doing, like 2-layer and 3-layer wire mesh was in place.
Mm. And the next question is also from Harinder Singh. How was the area at Hutman was monitored on daily basis for any settlement change?
Yeah, we were regularly looking into this data. In fact, the CSF hostel building was there, which is 3-story. We kept a total station at top of it, and we could able to have some few 3D targets and few of the attachment areas to monitor. And every day the people were going, and some few of the BSM building settlement markers also installed, and some of the surface settlement markers also installed in those areas, so that we were regularly checking it, and few cracks also been appeared in few of the buildings, so that we could able to monitor with a reduced frequency.
Okay, and the next one is from Sushil Sirsad. He asks, what is meant by four polling, how it is done, and what type of material is used?
So basically, see, four-poling is something that above the crown to have a extra additional stability. So that is how it is used. There are several, like we have a called like pipe proofing method, and we have a four-poling with the normal rock bolt, like normal steel rebar with the grouting hole. So like we have a 40 or like 25 dia or 32 dia bar, we can drill it. First, we'll drill the hole and we'll have a bar inserted with the packers, and we'll grout it. So that's how the four poling been done after the every excavation, NATM excavation.
Okay, this one is from Anonymous. How could you please explain more about numerical modeling and how four polling is modeled?
Four poling as such, we cannot able to model in the numerical this one. So we could only do the shotcrete and the complete modeling of the layers along with the rock bolting arrangement. Four poling has to be done with an empirical check. So we cannot model in the FEM.
The next one is from Vijay George. He asked, how much time taken to complete Caesar crossover?
Excavation time was around 2.5 3 years, 2.5 years, but this was only around very short span, because this additional scope of the works we got after 1 year of the project. So we took at least around 14 or 15 months to complete the excavation. Now the final final lining concrete is ongoing. So one additional thing, information, since we were not part of the final lining job, so that is being done with the sprayed lining. This is first time in India which is being done with the sprayed inner lining and not with the cast in situ.
Okay, the next one is from Sanskar Patiaria. What is the lifespan of these tunnels?
100 years.
Next, it is Vishal Kumar. He asked, have you done any building risk damage assessment due to tunneling?
Definitely. We had done initially with the TBM tunneling, the building risk assessment. And again, we had done with respect to the crossover excavation, what is the damage which we are expecting. Then only we could able to get the protection of those hutments and the CSF building, which is on top of it.
The next one is from Likon Biswas. What is the volume loss noticed during excavation and what is ground settlement observed?
The ground settlement was around 6 mm. So that's what we this one. I think the volume loss is not much during the TBM excavation also, which we have done. So it's less than 0.5%.
Rajiv asked, could you please explain more about numerical modeling and
I think the same
how
question.
it is same question, it was already explained. And the next one is from Bandiru. Is instrumentation monitoring done after final lining? What parameters are measured?
Yeah, actually this was being discussed also, because after this is one of the sprayed concrete lining which is being done. So they were doing some strain meters are to check the stresses after the final lining, but it is not required as such once the final lining is done and all the testings which we are doing. And if the test results are showing that it is durable, then there's no requirement to have this one. But anyway, for initial monitoring, we can keep it for 1 year up to the completion.
Ashutosh asked, is there any specific instrument to monitor Hartman area?
No, we cannot, like as such we have that only some BDSM points where these walls were there, but we used like point markers to just check the settlement, and the crack meters were installed in one of the worst areas. So that is the only thing. In that means not much we can do.
P. Vijay Kumar Reddy asked the rock musk removal. What type of machine used and what type of mix is used for shotcrete? Is any specific chemical used in shotcrete?
Yeah, we have this polypropylene, which is being used in the short pit, and we have the rock muck removal. So there were dumpers were there inside, and the breakers were there. So we used mini dumpers, and since the station was accessible to us, all the materials were shifted to the station, and we used lifting machineries from the station to excavate these materials.
Okay. And next is Pratap Kumar Sinha. Why two single tunnel were considered and preferred over a single twin tunnel for two lines?
This was the operational. So this is client is already planned to build the twin tunnels there. So there's no choice that we have to build it.
And next one is from Susil. What issue you faced in procurement of material, especially when the supply chain was disrupted due to COVID-19?
Yeah, I think the procurement team was quite good in order to look into these perspectives. So since normally whatever the materials which we are using into the construction of the NATM and even for the excavation, open excavation, the same materials being used here. So not much concerns like specific materials or specific requirement is to be done, but only testing took so much time on this.
Okay. The next one, it was how much time taken to complete entire Scissor crossover? I think this was
Yeah.
answered before. Next is from Rahul Sahai. We have been using TVM for a project in Mumbai. How is the process different from NATM Scissor crossover?
I think I did not understand the question, but as I can say, like after the completion of the tunnel boring machine, then we started this NATM crossover here. So I don't think what is trying to answer the question.
Next is Lok Srivastava. He asked, what is the direction of 4 poles and rock bolts with respect to excavation of enlarged section?
Yeah, like direction is around 20-degree inclination upwards. So we are using the rock bolts, and we were lapping like 4-meter lock bolts for the short length, short excavation, smaller excavation. And with the bigger cavern kind of structure, we are going for the 6-meter length of the 4 poles.
The next is Bandru. What are the advantage of GFRP bolts over SM type bolts?
So since we are doing the pre-inserts of the bolts, we need to break it again. Like once the segment is being removed, I have to again achieve that section. So because to achieve that section, I need to break that bolt. With SN bolts, I will disturb the complete rock mass over there. So with the GFRP, we can easily cut the bolt and proceed for the excavation.
Okay. The next is Rajiv. What software you used for designing, drawing, and numerical modeling?
I think for designing, we have the RS2 and the empirical methods also being used. Unweds also used. For drawing, we had the CAD and the beam models being done on these areas.
Okay, next is Yogesh. Yeah, as during presentation you mentioned of water seepages, how was it tackled?
Yeah, in few areas only we observed this kind of seepages. It was like channelized the water to the sump, and from the sump we started pumping it out to the station.
Next is from Piyush Kumar Singh. Which type of tunnel is preferred, rectangular or circle?
It's circular one.
In case of collapse, what was contingency plan?
Contingency is that whenever we had during the excavation, we have the continuous monitoring, even the real-time monitoring was placed. So any of the deformation which we observe, during that time, we will try to evacuate the surface if we feel that there's a collapse which is going to happen at first instant. Then we have to look for an grouting option within the tunnel or from the surface if such kind of emergency arrives.
Next is from Abhishek Raj. Which lining material is useful for sill-driven tunnel in sub-aqueous region?
It's for TBM or for the NATM.
It's not
Normally, it's
specifying for tunnel.
normal M45 is good enough for the lining.
How did you deal with seepage water? Any grouting done?
Yeah, a few areas where these dam patches were there, so we could able to drill small holes and do some kind of holes with very fine cement mix, so we could able to get that protection.
Next is the Deepthi. What is the reason for different size for each segment?
Like as mentioned, like we have the A, B, C, D, E, F blocks. So with respect to the dimensions which you are mentioning.
Does slurry type TVM induce less ground deformation than that of
Yeah, it depends on the
ETV
ground.
TVM?
It depends on the ground. So slurry TBM generally use in the mixed ground kind of areas. Yeah, it depends on the ground condition.
Which IS code were used in design of the crossover? Have you used any international code as well?
Yes, yes, we have mostly the international codes and ITA guidelines.
Have our numerous metros standards on their P and Cs dimensionally?
What is
I
P
think I
and C?
don't know
Yeah,
what he means.
exactly.
Okay, next one. How to rectify how
Yeah,
how to rectify
his question, yeah.
distorted
Okay,
yeah
like
how to rec
since we were doing an excavation adjacent to a permanent segment, so there could be chances of distortion of these segments which is to be there permanently. So what we
okay.
did is we had the steel ribs in place for the precast segments in the tunnel. So for some extent we had done the steel ribs to protect the segments to avoid any deformation due to breaking of the segment or anything. Then the adjacent segments were taken into consideration for breaking.
Okay, next one is from Lal Babu. How much cement required per meter for poly?
That I don't know exactly, but we need to check with respect to the length of the fork pulling.
Okay. Next is from Vijay Raman. Are there any moves to use electrochemical machining for standardized PNC, as well as the reverse for repairs and maintenance? That is electrochemical deposition. This would collectively be an area of reducing cost of material as well as downtime for wear and tear of traffic blocks.
I think basically this is about the machinery. Maybe he's asking. So I
Yeah.
think a lot of machineries were there. It's not much ever about this construction issues.
Okay. Next is from Devashish. In future, after tunneling area, there would be no boring or digging allowed in the Hartman area. It might cause any physical damage to tunnel.
They will not allow to do any drillings or anything since we are quite deep. But anyway, even for any drillings, they need to get the permission from the client. So that is in that zone. That's very clear.
Benefit of final lining using sprayed concrete.
Yeah, that advantage of having a sprayed concrete is we can avoid the shuttering, and the time, like the span of the time, we can easily complete it with reduction of time. So that is an advantage always we have with sprayed concrete.
Okay. What type of contract adopted and how did you select the contractor?
It's a question to the client we need to check. It's an EPC contract basically.
It is already done. I think how water seepage address
Yeah.
during. Okay. The next is GFRP bolt can be used as a permanent bolt.
Yeah, definitely, because it have the same strength of the rock bolt, even with the SN bolts which we have.
Next is from Amit. How much is the cover over crossover?
7 to 9 meters.
Okay. What is the dia and length of TBM?
Dia is internal dia is 5.8 meters and external dia is 6.35, and with the cutter head dia of 6.7 meters. The length comes with around 100 meters, including the backup of the TBM.
What is the total length of this type of tunnel?
So this crossover is around 227-meter length, including all the sections.
What if the distortion happened during the operation period? How it is rectified?
As such, we did not face any much issues, but if it was done, we could have rectified with some additional grouting, or since it is temporary for the primary support, we can go for some small grouting here in those areas.
What happens if earthquake comes during tunneling?
Yeah, during tunneling, if it comes, so we need to accept it. And we anyway, for the final lining, we'll do the seismic design for all the final lining. So that we have already taken considering the seismic zone of the movement.
So next one is P. Vijay Kumar Reddy. Is there any precast members used in tunnel zone?
We did not do any precast membrane, like board segments are precast segments. So that is the only thing which we have used here, both tunnel segments for the T-beam.
Nikhil asked, what are the safety measures adopted while doing sprayed concrete and how it is measured that how much thickness of final lining have been done?
So basically they are checking the layers of the shotcrete thickness. So the equipment team is there. So they have a sensors which you could able to check the thickness during the construction.
Next is Prasiddha. It was seen in the image that each segment were of different size. Shouldn't the same size be used throughout the length?
Yeah, that's what the initial proposal which we have shown. So if we can go with the taper, one is that I will not be able to excavate with the taper zone. The other areas where the extra clearances which are required between the tubes were not available to go with that kind of same tubes sections.
Sunil Kumar asked, what is the material used for waterproofing?
It's normal, the NATM, whatever we are using, the same waterproofing is there. But here, additionally, since the sprayed concrete lining is in place, a sprayed waterproofing membranes also been done. So that is being done by the other designers, the entire complete final lining of this sprayed this one. We did the design for the cast in situ, but it was ruled out. Then they went for a sprayed concrete lining.
Okay, the next one is steel fiber reinforcement can be used in both temporary and permanent lining.
Yeah, exactly. We can use it.
And I think this is the last one. No, we have no. Did any cavities form during excavate?
Not cavities, but we had some instances where we got some small cracks in the dimensions. There was small movement which we observed, but all those were tackled by reducing the braking, and because that we could able to manage the equipments with respect to the vibrations. Also, we kept the monitoring there, so that we have reduced it.
Okay, now this is the last. How the drainage system has been managed in crossover areas where section profile is changed?
That drainage system, like basically we have the first stage concreting is done. So we have a scupper drainage arrangement on at the bottom. So each where these variations are coming, so that is being curved, like a small curve is being done. Basically, the scupper drain arrangement will not have much issues there.
Okay, the next one. What is the method of tunnel in soft area?
Soft grounds, we can go with the cut and cover if the space is available. If the tunnel has to be done, we can go with the TBM. Even NATM can be done with an improved ground.
Which material used for protection from soil collapse?
Yeah, it's we can go for a cement mixed grouts with some additional add mixtures if required.
Okay, so we don't have any more questions. I think we end here our Q&A session. So now we are reaching to the end of our webinar. Due to some reason, I think Mr. Alok Bhaumik sir has not joined us.
He has joined. He has joined.
I've joined. I've
Okay.
joined.
Okay. Sorry, sir. So, as you say, we have reached to the last of our presentation. So, I would like to request Mr. Alok Bhaumik sir to give us a closing remark and vote of thanks uh, uh, before we end this presentation.
Thank you. Thank you, Ajay ji. Actually, I'm really sorry for finding, at the fag end. Unfortunately, I could not attend the webinar and the presentation because I was in some other meeting. But looking at the number of registration and also the number of participation, as I can see now, we have more than 130 participants and we had more than 450 registration. I'm quite happy that initial, as far as the participation is concerned, it is quite satisfactory. This is the second webinar that is being organized by our Future Leader Forum in last 1 month. I think the last one was by Dr. B.C. Roy in the month of April. And for those who may not be aware about our this Future Leaders Forum, let me state that it is a very important arm of our CEI Governing Council. They are our future, and this is a platform which is provided in CEI Governing Council so as to promote and empower our young professionals to participate effectively in shaping the future of our industry, particularly the consulting engineering fraternity. I take this opportunity to thank all the members of this Future Leader Forum, which is led by the chair, Mr. Mihir, and for taking this great initiative. My thanks to the speaker of the day, Engineer Pratap Muniappa, who has shared his experience and knowledge on this NATM and crossover for the metros. I'm sure this lecture would have inspired not only our young professionals, but this would have also helped the speaker himself to gain added confidence. And this is one area where I would like other young engineers who are participating to also take cue, and if some of them are willing to come forward and participate as a speaker, please express your willingness. We would be too eager to give you an opportunity to share your knowledge, your wisdom, and your experience with us. I sincerely thank our secretariat team for doing all the background work. They are unsung heroes, but they are very, very essential for success of our webinars. Special thanks to Mr. Sudhir Dhawan, who is an inspiration to our young engineers. The very fact that he spared his time to address the Future Leader Forum in this webinar itself means a lot. And I think the young professionals draw a lot of inspiration from his presence. Last but not the least, a big thanks to the participants, without whom we can't organize anything. And I would appeal to all the participants to please support this Future Leader Forum by active participation in future also. I would like to hand over to our moderator now, Mr. Ajay Kumar Singh, to take it forward. Thank you.
Okay. Thank you very much. Thank you very much, Alok sir. It's very nice to hear from you such encouraging words. So as we end this presentation, I would like to thank Sudhi sir for giving us the objective of explaining us the objective of CEI and encouraging us to come forward and give opportunity to young engineers. I also want to thank our chairperson, Mr. Mihir, for organizing such a webinar series, which will useful for young generation of engineers. And I will thank Mr. Pratap to give us a insight about the underground construction. How can we face the challenges in this type of typical and complex structures? And last, I will thank Mr. Alok sir for giving the thank you notes. Thank you very much. And with this, we can end this presentation.
Thank you.
I have
Thank
only
you.
one.
Yeah.
Yes.
Go ahead, Alok, go ahead.
Yes. Please speak, Sudhir sir.
I have one request to future leaders. Please join CEI membership, and we would like to welcome you all. And we have a very dynamic future leaders group here, and we want to make it even more. So please do apply and become members of CEI. Thank you all, and we can close the